Hello data enthusiasts, and welcome to my video about data visualizations using R and Python. In this video, I will show you how to use these two powerful languages to create beautiful and informative visualizations of your data. I'll start by giving a brief overview of data visualization and the different types of charts and graphs that you can create. I'll then show you how to create these charts using R and Python and get started using them. I hope this video gives you a good introduction of data visualization using R and Python. If you have any questions, please leave a comment below. When we explore data, even after applying advanced statistical techniques, some patterns are best understood through visualization. As the saying goes, a picture is worth 1,000 words. Visualizations are powerful tools for asking and answering questions about data. There are four main types of visualization we can use, depending on the question that we're trying to answer. First, we have comparison visualizations. These helps us see the difference between two or more items at a specific time or over a period. One common example is box plot, which let us compare the distribution of continuous features against a categorical feature. For instance, these box plots compare annual salary among different titles. From this, we can see that directors and managers have higher annual salaries than other job titles. Comparison visualizations reveal insights like the significance of a feature, variation in median or mean values across subgroups, and the presence of outliers. Next, we have relationship visualizations, which illustrate the correlation between two or more continuous variables. Scatter plots and line charts are frequently used for this purpose, showing how one variable changes in response to another. For example, the scatter plot illustrates the positive correlation between the salary and years of experience. These visualizations highlight interaction between features, their significance, and any outliers. The third type is distribution visualizations, which depict the statistical distribution of a feature's value. Histograms are a common example, helping us identify the most frequent values. For instance, this histogram shows us the salary for a job range from around 50K to 150K annually, and it appears that the distribution is not normal. There is a skewness that might be due to the fact that some employee earns significantly more or less for this job. Distribution visualizations show the spread or skewness of values and highlight outliers. Finally, we have composition visualizations, which display the component makeup of our data. Stacked bar charts, grouped bar charts, and pie charts are typical examples. For example, the stacked bar chart right here illustrates the distribution of employees across different departments over the years. It shows how the number of employees in each department has changed from 2019 to 2022. This visualization helps you easily compare the contribution of each department to the total number of employees over time. Composition visualizations illustrate how the contribution of subgroups to the total and any changes in subgroup composition over time. Now, we will be using Python to create a variety of graphs that will help us understand supermarket sales data. We'll use pandas to handle our data, and Seaborn and Matplotlib to create beautiful informative visualizations. Let's get started. First, let's import the necessary libraries. We will need pandas for data manipulation, Matplotlib for basic plotting, and Seaborn for advanced statistical visualizations. If you don't have these libraries installed, you can install them using pip. Before we dive into the code, let's discuss a brief introduction of the differences between Matplotlib and Seaborn and when to use each. Let's start with Matplotlib. Think of it as the Swiss Army knife of data visualizations. It's incredibly versatile, allowing you to create any type of plot imaginable. From simple line charts to complex 3D visualizations, Matplotlib has got you covered. Now, let's see Seaborn. Imagine Seaborn as a pre-built theme for your Matplotlib plots. It provides a higher level interface, making it easier to create visually appealing and consistent plots with minimal efforts. Seaborn builds on top of Matplotlib, offering a collection of pre-designed styles and color palettes. So, which one to use? If you need granular control over your plots, or if you're creating something truly unique, Matplotlib is your go-to. If you want to quickly create visually appealing plots with minimal code, Seaborn is a fantastic choice. Let's see a quick demo to illustrate. Now, we load our dataset. We're using a CSV file that contains supermarket data cells. The read CSV function from pandas will help us load this data into a data frame, which is a powerful data structure for handling tabular data. Now that our data is loaded, let's set up the visual aesthetic for our plots. We'll use Seaborn's set function to choose a clean white grid style that will make our charts easy to read. Let's start with a comparison graph, a box plot. Remember, a box plot helps us visualize the distribution of data and identify outliers. In this case, we'll compare the total sales across different product lines. Let's run this. In this plot, each box represents the interquartile range of total sales for each product line, with the whiskers extending to show the rest of the distribution, excluding outliers. We create the box plot using boxplot method from Seaborn. We'll add the title using plt.title method, and then we rotate the X labels with 45 degrees in order to make the plot easier to read. plt show shows us the final plot. You can see that sports and travel have the highest median total sales. Electronic accessories and health and beauty have the lowest median total sales. Another finding suggests that fashion accessories have the widest box, indicating a larger spread of total sales among different data points. Food and beverages have the narrowest box, suggesting a more consistent distribution of total sales. Electronic accessories and fashion accessories have outliers, suggesting that there are a few product lines with these categories with exceptionally high or low total sales. Next, let's explore the relationships between two variables using a scatter plot. We'll plot the unit price against the quantity sold and color the points based on the product line. This can help us see if there are any correlation between the price and the quantity for different product lines. This scatter plot visualizes the relationship between unit price and quantity sold for different product lines. Each dot represents a specific product with its corresponding unit price and quantity. The color of the dot indicates the product line, which we basically set using the hue argument. This scatter plot is useful for identifying trends and patterns, such as whether higher priced items tend to sell in lower quantities, or if certain product lines have a distinct relationship between price and quantity. The overall observations of this plot are: product lines have distinct price ranges, but there is some overlap. Quantity sold varies within each product line, with no clear correlation to unit price, and outliers suggest that there are few products with unique characteristics that deviate from the general trends. Let's move on to distribution graphs. A histogram is an excellent way to see how data is distributed across different ranges. Here, we'll plot a histogram of total sales to understand how sales are spread out. The histogram shows us the distribution of total sales amounts with the option to overlay a KDE, kernel density estimate, for a smooth distribution curve. This helps us see where most of sales amounts are concentrated. Let's discuss the key finding of this plot. Most products or customers have total sales between 100 and 150. There are few products or customers with significantly higher total sales, which skews the distribution to the right. The distribution is relatively spread out, indicating a range of sales performance. Now, let's create a composition graph using a bar chart. This bar chart will show us how different product lines contribute to the total number of sales. Bar charts are great for comparing quantities across different categories. In this bar chart, each bar represents the number of sales in each product line. It's a simple yet effective way to compare the popularity of different product lines. Let's discuss some key findings of this chart. Food and beverages have the highest count, followed by health and beauty and sports and travel. Electronic accessories and fashion accessories have the lowest counts. All product lines have a relatively similar number of items, with a slight variation. For a more detailed composition graph, let's create a stacked bar chart. This chart will show us the distribution of product line sales, further broken down by gender. Stacked bar charts are useful for understanding the composition of different groups within a category. Each bar is split into a segment representing gender, allowing us to see each gender contribution to the sales of different products categories. We can clearly see that female customers tend to purchase more electronic accessories, fashion accessories, food and beverages, and home and lifestyle products. Male customers tend to purchase more health and beauty and sport and travel products. Electronic accessories are the most popular products line among both genders. Fashion accessories are the least popular product line among both genders. Lastly, let's create a pie chart to visualize the composition of gender in our dataset. Pie charts are ideal for showing the proportion and percentages within a single categorical variable. In this pie chart, we can easily see the proportion of male and female customers, which gives us a quick insight into the gender distribution within our sales data. 51.3% of the sample is female, 48.7% of the sample is male. The gender distribution is relatively balanced with a slight majority of females. And there you have it. You've covered several types of visualization using Python, Seaborn, and Matplotlib to explore and understand supermarket sales data. These charts can be incredibly useful for identifying trends, relationships, and distributions within your data. Remember, if you have any question about these charts or more, leave a comment below. And let's head in quickly to how we can translate this code into R. In this final section, let's dive into data visualization with R. Using the powerful ggplot2, also, we'll sprinkle in some handy tips along the way to make your experience even better. Let's get started. First things first, we need to set up our environment. We'll be using two K libraries today, ggplot2 for plotting and dplyr for data manipulation. Let's load them up. As usually, if you don't have these libraries installed, you can easily install them by running install.packages and R will take care of the rest. Next, let's load our dataset. We're working with supermarket sales data stored in the CSV file, so we'll use read CSV to bring this data into R. With our data loaded, we're ready to start visualizing it. But first, let's ensure our data is clean and structured. It's always a good idea to inspect your dataset before juggling into visualizations. So, we used the head method to preview the first few rows in our dataset. We can also use str to get a summary of its structure. This can save you from headaches down the road. Let's kick things off with a box plot, which is perfect for comparing the distribution of total sales across different product lines. As box plots allows us to quickly identify the median, range, and any outliers in our data. This box plot gives us a clear comparison of total sales among various product lines. The boxes represent the interquartile range, while the whiskers extend to show the rest of the distribution, excluding outliers. Notice how we use a theme to rotate the x-axis labels. This trick is super handy when your category names are too long and overlap. Next up is the scatter plot. This graph is great for exploring the relationship between two variables. We'll plot unit price against quantity and color the points by product line to see if any interesting pattern emerge. Let's go ahead and run this. This scatter plot reveals any correlations between unit price and quantity sold across different product lines. It's an effective way to spot trends and outliers. Histograms are perfect for understanding the distribution of a single variable. Let's create a histogram to see how total sales are spread out in our dataset. In this plot, the bars represent the frequency of total sales within specific ranges, while the red line overlays a density plot to give us a smooth estimate of the distribution. Use bins to control the number of bars in your histogram. A higher number of bins gives more granularity, but too many can make the plot noisy. Bar charts are great for comparing quantities across different categories. Let's create a bar chart to see the distribution of sales among the different product lines. This bar chart shows us the count of sales in each product line. We use the reorder to sort the bars by count, and chord flip is a simple yet effective way to improve readability, especially when you have long category names. For a more detailed composition graph, we create a socket bar chart. This will show us the distribution of product line sales broken down by gender. Each bar in this chart is split into segments representing different product lines, allowing us to see how each gender contributes to the sales of various products. Stacked bar charts are great for showing composition, but be careful. Too many segments can make them hard to interpret. Finally, let's create a pie chart to visualize the gender distribution in our dataset. Pie charts are ideal for showing proportions within a single categorical variable. This pie chart shows us the proportion of male and female customers. The labels display the percentage each gender represents, making the chart easy to interpret. Use Team Void to remove unnecessary chart elements, keeping the focus on the data itself. And there you have it. We've covered a wide range of visualization using Python and R. Whether you're comparing distributions, exploring relationships, or understanding compositions, these tools will help you tell compelling stories with your data. If you enjoyed this tutorial, please give it a thumbs up, share it with your friends, and subscribe for more content. Thanks for watching and happy plotting!